let's get started. Okay, combinations. If you remember last time we talked about permutations, and that had to do with the way things are ordered. Okay, we had the example of ABC and how it could be written as BCA, AB, or CBA, etc. There's 6 different ways that you can do that. Today we are going to be learning about combinations. So combination is a selection of objects from a set without regard to order. The number of combinations of n distinct objects are taken r at a time, and it is written as NCR. So again, n represents the number of total objects, and r is how many we are doing at a time. If order is important, you are finding a permutation. However, if order is not important, you'll be finding a combination. So let's take a look at our first example. Combination or permutation? Let's see. The number of ways to place 5 pictures in a line on a wall. So we have 5 pictures and we're putting them on a wall. Does order matter? Yeah, I think order matters there. So your answer is going to be a permutation. Let's look at this one. The number of ways to fill 4 8th grade class offices from 7 nominees. Let's see, what do you think? Do you think order is important? Yeah, I think order is important too. There we go, that's a permutation. The number of ways to choose a 5-person class party committee from the 12 volunteers. So 12 volunteers, and it could be anybody? Well, if it can be anybody, in that case, order does not matter. So it's a combination. Our formula to find combinations looks a lot like our formula for finding a permutation. So if you remember our permutation formula, it was just n factorial over r n minus r factorial. So today we're adding a little buddy, and he's going to hang out below, and that is r factorial. So now it is n factorial, which represents the total number of objects, over r factorial, which is how many we're taking at a time, times n minus r factorial. Let's see how we can apply this to our second example. Use the formula to find the number of combinations of 3 books that Caitlin could choose from the 7 new books that she bought. And I see that typo, just ignore that for a minute. So first of all, I'm just going to replace the values into my formula. So we have 7 new books, and she wants to know the number of combinations for 3 books. So 7 is my n, 3 is my r. So that gives me 7 factorial over 3 factorial times 7 minus 3 factorial. Our next step is to simplify. Okay, so I went ahead and I wrote it out as 7 times 6 times 5 times 4 factorial. Why did I stop at 4 factorial? Because I see it again on the bottom. And if I don't have to write that all out, then I won't. I'm going to try to cancel it. So I expanded that 3 factorial to 3 times 2 times 1 times that 4 factorial. We're going to cancel that 4 factorial on the top and bottom. And then let's see, what else can we cancel? We have 3 times 2 times 1 on the bottom, which is 6. We also have that 6 on top, and I wish I could have some sort of animation to cross that out. I'll figure that out next time. And then we are left with 7 times 5 over 1 on the bottom. 7 times 5 is just 35. Okay, let's take a look at our third example. There are 10 girls in Miss Dundon's class, which we know that's not true. But anyway, for the sake of the problem. And there are 6 to be selected for a volleyball team. How many different teams can be chosen? Okay, well, no order doesn't seem to matter there, so let's plug this into our combination formula, which is right there on the left. Okay, we have 10 girls, that's our n, and our r is 6, because that's how many we are selecting. So we have 10 factorial over 6 factorial times 10 minus 6 factorial. Again, I'm going to expand this out, but I don't want to expand it all the way because I want to see if I can try to cancel something. And I see that I have 6 factorial on the bottom, so I'm going to keep that 6 factorial on top so I can cancel it. When I cancel that, let's see, I have 10, 9, 8, and 7 on top, and then 4, 3, 2, 1 on the bottom. It looks like I can cancel that 8 out with that 4 and 2 on the bottom, and then that 3 can go into that 9, which will be 3 on top. So that leaves me with 5, or 5 times 3 times 2 times 7, and then that is all over 1. 5 times 3 is 15. 15 times 2 is 30. 30 times 7 is 210. All right, so that is it for our combination lesson. And if you have any questions, just feel free to let me know and I'll help you. All right.